It's a real pleasure to be here. Southeastern Oklahoma is a very special place to me, especially the Ouachitas and the Comanche Valley. And it's not every day that I get to talk about water and our forests at the same time. And to me, they're inseparable. When you're talking about one, you're really talking about the other. And so it's kind of exciting for me to be here and to present some of my research. So I'm Russell Doughty. I'm with Oklahomans for Responsible Water Policy. We were formed in 2010. We have about we have over 15,000 members, grassroots, and formed really over the Sardis Lake issue. But since then, we've been paying attention to larger water issues in the state, especially what's going on legislatively at the state capitol. And so, but what I'd like to talk about today is my research at Oregon State. And my research at the Oregon State Corvallis, when I first started, they asked me to pick an area, pick a forest or some natural feature that means something to us, and that's what we're going to study. And so me, of course, I chose the Ouachitas, and I wanted to focus on the Oklahoman side of the Ouachitas. I know it's a large area. No one at Oregon State had ever done that, at least not to the knowledge of my professors. They had no knowledge of the Ouachita Highlands. They kind of heard of the Ozarks before, but they really weren't familiar with the Ouachitas. So when I ventured into this, they didn't even know how to say Ouachita. There's like, it's spelled with an O. What's this? You know, the Comanche, you know how there's a million ways to say it. And I said, okay, this is how the locals usually say it. And so it was a real journey for me, and I think for our professors too. And so I learned a lot of, I got to see firsthand a lot of amazing things they're doing at that university with science, with satellites and so forth. And I got to ask some of the questions they're asking about the forest up in the Pacific Northwest, and start asking some of those questions about the Ouachita forest. And some of these questions, through my research, I couldn't really dig up, but these questions really been asked or kind of dug into before. So anyway, I found out, and I think I can prove scientifically that Southeastern Oklahoma is unique and it needs to be defended at all costs. Our water and our timber resources are vital to our economy here. And we talk about, the state legislatively right now, they talk a lot about the budget shortfall, oil and gas is declining, and so on and so forth. Well, to me, I look at Oklahoma and I say, well, what kind of sustainable economies do we have? It's timber and it's water. It's the recreation tourism that we get off of our water and timber resources. And those are sustainable resources to me and sustainable economies. Okay, so in the future, to me, what does Oklahoma look like in 100, 200 years? The economy might be largely based on agriculture of crops in the west, maybe, and forests in the east. Okay, so it just kind of frames some of the discussion. And I've never done a presentation this way. I'm going to try to do it from my tablet, so this is a new technological advancement that I didn't come up with. And if you have any questions, feel free to break in any time. I'm going to try to get through this as quickly as possible. I have about 30 slides. I'm going to go through about 2.5 years of research that I did. And all the papers that I wrote and everything I did was on the Ouachitas. I didn't study the Klamath Valley and the Columbia and tribal rights and all that stuff that they usually study up in the Northwest. I studied solely whatever I could dig up on our forests here. And I would love feedback from anybody too, because this is all still new to me, and I know that you all have way more experience and knowledge than I do. So I'm also here to learn from y'all. Maybe y'all give me some insight. So really, some of the questions that drove my research are some of these kind of childish questions, like, well, how does the world work? You know, it was great at undergrad. I got to talk about philosophy and things, but then when I got into my master's, I really wanted to know, well, how does the world really work? Things like astrophysics and space and the sun always interested me, and I wondered what's going on Earth here, what's driving everything. But then I got into forests and I started to realize what kind of role forests play in the movement of water and nutrients on Earth. And so I started thinking, well, what role do the water, wow, I didn't know that. So what role do the Ouachita Highlands play in perhaps our climate and land use and so on, our economies? Then I asked more specifically, well, what is the role of Ouachita Highlands in biogeochemical nutrient cycling? Big fancy word. Normally, we focus down here on, I think I had a point on the carbon cycle. So there's been a ton of research, especially at Oregon State, on the carbon cycle. Mark Harmon is he's one of my professors. And there's been a ton of stuff done on carbon. But what I was interested in was, well, what's the role of forests here in water and our nitrogen cycles? And those are questions that weren't being explored as much, nearly as much as the carbon. Okay, so I started looking at Southeastern Oklahoma, and I'm going to jump to our conclusions. I'm going to the last slide right now. And just to tell you what I found, because it's extraordinary, and then I'm going to go through and explain why and how I found it. This is what I concluded, that the Ouachita Highlands are a very unique place, that our climate here in Oklahoma is not only driven by global factors such as El Nino, but it's also driven by local factors such as the health of our forests. A healthy forested Ouachita landscape might mitigate the impacts that are expected from climate change in the future. So we're talking about the earth heating and less rainfall and so forth. And I think that our forests could be looked at as one option in mitigating those harmful impacts that we could have in the future. And I learned that a healthy riparian forest is necessary for watershed health. And that's what this quote down here is. It's from a very famous professor in water biology, Robert Naiman. And he said, the heart of an ecologically healthy watershed is the riparian forest. This strongly suggests that the maintenance of riparian forests is of fundamental importance for long-term ecological and socio-economic vitality of watersheds. So it's not just the natural systems that evolve around watersheds, it's our society, it's our economies, it's everything, okay? I learned that the nature of fresh water is a cycle, and that it's the sun and trees that power that cycle. And often up in the Northwest especially, they look at trees and they see carbon. Well, I would look at trees and I see water. And not necessarily that they store so much water, but that they have an amazing ability to transport water into the atmosphere and underground.
Hold on a minute.
Sure.
I got distracted food. Go back to that slide. I was trying to read the bottom. Give me your definition again of criteria of forest.
Right, so it'd be a zone of forest along a stream bank or a riverside or a creek. And that's
protection zone.
Right, yeah, and you'll see, you drive around, Weyerhaeuser's done a great job of leaving riparian forest and corridor along our creeks and streams.
Okay.
Again, that helps filter out any nutrients that might get into our creeks and streams and filter into, larger rivers like the Glover River.
Okay.
So, and those are the riparian areas.
Okay.
And so the health of our watersheds, our streams and our creeks are directly tied to the health of the forests that are around our streams and creeks. Is the point there. And so I had some hypotheses. These are my hypotheses. I think that we need to explore these questions more, especially at the university. I hypothesize a healthy forested Ouachita landscape can mitigate the effects of climate that are predicted by climate science. And I think that the climate of western Oklahoma might be directly influenced by the health of our forest here in the east. And I'll explain that a little bit more. Now, we're all familiar with this idea of succession, that we have some sort of catastrophic event, it kind of resets our forest back to zero. And we kind of go through time. Here's time. And as time goes on, we go from basically whatever says here, maybe agriculture. It could have been a volcano, a forest fire, anything. And then we go back in several hundred years, we end up back into old growth forest. And as we go through this, we tend to have a succession of species too, and a change of species composition. And so we're kind of familiar with this concept, I'm sure, already. We learned it early on in forestry. But I wanted to expand the same concept over larger time and space. Okay, so if you're thinking, okay, how our forests change, they go from young growth to old growth, periods of hundreds of years, between thousands. Well, what happens to our forests over the course of tens of thousands, maybe even 100,000, 200,000 years? Now, this is what the science is telling us. This is from NOAA, and this is a simulation of what the ice sheet looked like during the last glacial maximum. And that's during an ice age. It's a fancy word for ice age. A glacial maximum is that point that during an ice age where you have the most glaciation on Earth. And so you can see where glaciers on Earth, they come way down here into North America. Okay? And then this is the modern day over here on this side. And so you can see how small the ice sheet is. Okay? So the Earth, over time, kind of pulses in this respect, that these sheets get larger and smaller. And these are largely driven by factors that we don't even yet understand. Ocean temperatures, solar cycles, and so on. And so, well, what happens to our forests during this time period? What's going on there? That's what kind of made me curious. And I thought, well, what did our forests look like during the last glacial maximum? And this is it. I found a journal article that had this little image in it, and it shows the range of loblolly, shortleaf, and then patches of jack pine up in here. And the pines that now cover the entire eastern United States were once confined to 200 miles within the Gulf of Mexico. Okay, so suddenly we're thinking about succession on a much more grand scale. Okay, so as the poles, as the ice sheets started to melt, you have a northern expansion of our forests, and they come back up. And then this happens over and over again over thousands and tens of thousands, hundreds of thousands of years. So we kind of have this flux of species going in and out. And so this would be kind of the natural flux of forests if humans weren't involved in land management. And of course, since we are involved in land management, we've really inserted ourselves into what would be the natural grading up of the earth as the ice sheet melts and as the earth warms. Most of you probably know the earth is missing about half of our original forest cover from when we started logging. And with the retreating ice sheet, theoretically, you should have a growing forest up in the boreal, for instance. You'll have more growth. So this got me to really thinking about how have we inserted ourselves into our forests and the way that they cycle these nutrients and things. So briefly, we're really all familiar with the climate down here, but these are some really powerful images. These gradients, these are precipitation gradients across Oklahoma. This is from the PRISM network at Oregon State. And these lines, you'll see these gradients, these areas of high pink, fluorescent pink. These are areas that have the most rainfall. Now, Oklahoma and Arkansas aren't directly comparable here. They're actually on a different scale. The hot pink in Arkansas is more than 64 inches annual average. And then over here in Oklahoma, this hot pink is more than 56. So this is telling us the Arkansas side does get a little more rain annually. But together, this really demonstrates that there's something going on in the Ouachitas with precipitation. We don't see it in the Ozarks. Now there's a little bit of enhanced precipitation falling there. And again, this is a 30-year average. And so you start looking at this and asking yourself, well, why is there so much rain in that spot? And I believe my next slide, exactly. So you'll see that these gradients literally follow the ridge lines, the top of the mountains. You'll literally see the east-west running ridge lines here in the precipitation gradient. Those are topo shadings underneath the precipitation gradient here. So I just wanted to, and you can see this, you just see this little outlier here in this, how it just perfectly follows the ridge lines. Where else in the United States can you see this? You can't. This is a unique feature, and it's smack dab right here in the middle of the United States. And to be honest with you, to my knowledge, very little science has been done to figure out exactly what's going on with our climate and our forests, in our topography, because it's the hills, it's a combination of the hills and the trees that are creating the conditions that are necessary for this type of precipitation. At least that's what I hypothesized. And then I got to looking, okay, well, we get a lot of lightning around here. They don't talk about lightning at all in Oregon State because this is a precipitation gradient map, and as you can see, they don't get lightning hardly at all. I was out in Oregon for 3-4 years. I never once saw a lightning strike. I heard thunder a couple of times. Okay. Now you look over here, and there's this big donut-shaped lightning activity going on. Again, this is actually cloud-to-ground lightning over a 20-25 year period here. And so this is also an average, and it shows us over time these trends that there's a correlation or something going on here. And then you look more specifically right here in southeastern Oklahoma, and there's a big hot spot of lightning production. Okay? And thankfully we don't get many forest fires relative to the Pacific Northwest. But we get all this lightning activity, which also made me wonder a whole bunch of other questions, which could be asked some other time. And I want to come back to this. We didn't know this until we put a satellite up and we started measuring lightning strikes until about 97. Lightning is almost a terrestrial event. 90% of all lightning strikes occur on land, not over oceans. Okay, so, and now, why is lightning important? Lightning and fungi are the only two sources of fixed nitrogen. How many tons of nitrogen are being fixed over the Ouachita Highlands? We have all this precipitation, all this nitrogen being fixed. So it gave me a unique opportunity when I'm studying the Ouachitas is to not only look at the carbon and water cycles, but to ask questions about the nitrogen cycle. And these are questions that they can't really ask out here. The fungi, soil health, is a much more important question to them because they don't have these inputs of fixed nitrogen from the atmosphere. So that needs to be investigated. Now this is an annual precipitation history for southeastern Oklahoma. And the storyline here, and you've probably all seen this, is that in my lifetime, starting around 1982 or so, we had a big wet period. We had a lot more rain relatively to historical record. So in my lifetime, basically, I've seen a very wet period. I don't know what, yeah, we just came out of a bad drought, but I don't know what these historical droughts look like. So we've been spoiled. And we've got to remind ourselves of that going into the future, that we're coming out of a period of a wet period, and we could be right down in here for the next several decades. Okay? And it might look like we have water now, but actually, in my opinion, we're kind of lucked out. And now this is also an annual temperature for statewide. This is statewide what's going on. And you'll see we had a cool period also. A very long cold period here in Oklahoma, but it's been heating up. Now, what I want to point out with this slide is there's something very interesting going on. You can pull up the same exact slide for only southeastern Oklahoma, and you'll see that these heat trends haven't hit southeastern Oklahoma as hard. You look at the other 8 regions that these charts exist for, you'll see that they have been hit by higher heat. For some reason, southeastern Oklahoma has we've seen an increase in temperatures, but not to the same degree as the rest of the state. And so it got me asking, well, what's going on with that? Well, we all know that the more forest cover you have, If you have 1,000 acres of forest and you go stand in the middle of that forest, it'll be a cooler temperature than if you stand in a grove of 100 trees, right? It's forest cover, it's leaf area index. So I'm starting to think here, these are giving us some tools maybe in forestry management, climate change, climate science. Now back to this, we all know this graph, we typically get, this is rainfall and temperature. It just shows we have our highest temperatures usually here during summer months. Those same months are the months we have lower precipitation. So now, what's going on globally in driving climate most generally? Obviously it would be the sun, but secondly, we've got these ocean temperatures, and it's El Nino and La Nina effect. And I have a diagram here for both, and what happens in an El Nino is this area of the ocean warms up considerably, and I think I can even blow that up a little bit. And you can see, so what happens when the ocean warms up, it sends the jet stream right down through the center of the United States, kind of through Albuquerque and then kind of through here. And it creates these different conditions. It leaves a warmer air mass here. And in a La Nina, you get a cooler ocean temperatures, and that jet stream is able to bounce around and it's more variable, and it can come up here way north of the Rockies and then pull in cold air into the rest of the United States. But when you have an El Nino, that isn't as likely. Okay, so that's really what, when they talk about climate change and climate science, this is the big driver behind the trends that we see between 4, 5, 6, 8-year trends with these temperatures. So, and then this is, I pulled this off of the internet today from NOAA. This is their latest image on ocean temperatures. So this is what it looks like right now. And you can see this is Central America here, and that's South America. And you can see how warm the ocean temperatures are. We have a lot of warming, not only here, but a lot of warming off the coast here at Wausau, which isn't as typical. So who knows where this El Nino is going to go. I looked at land use, and I was wondering, I couldn't find a very accurate number on how many forested acres we have left, how many have been logged, and so forth. It's kind of a tough number. But I dug into NRCS data that they had in 2009. They have some geospatial data you can go download. I went in their tables, and then I made these pie charts to figure out kind of where we're at with our land use. And we have 57% of our forests. I'm assuming most of southeastern Oklahoma was forested, virtually all of it. That this 57% before mankind was ever here was probably much closer to 90 or 95%. I don't know if y'all have a different feel on that. And then it goes to native pasture, there's 2%, and so there's some of these other uses, pasture land. And you can almost bet your bottom dollar a lot of this pasture land came from this forest, okay? So you can look at pasture land alone, some of these other lands, and start figuring, wow, we've taken a huge chunk out of the forest. And then you can look at, okay, now this just came out in an article by Karen Vaughn at the University of Oklahoma. She's the mussel lady. And they looked at some historical uses of land and the Comanche watershed. That's what this is, Comanche watershed. This is 1898 land cover and use. And okay, so they estimated 93.9%. So of the watershed was covered with forest. Whereas today they came out with a higher number than I did. They came up to 63% of forest. And that number is gaining. I know it is. A lot of people's pastures are going back and so forth. And a lot of lands are on rotation too. And I realize that. So some of this area that doesn't look as forested is forest. So the image could be a little distracting in that regard. But here's a comparison image. So this is a satellite image I took from Google Earth in 2013. And it shows the degree to which our forest is fragmented. And then I took Photoshop and I cut and pasted some trees into the valleys and stuff where we've cut them out, just to see what it would look like, because I wanted to get a mind's eye. And it's pretty remarkable difference to me. That's a pretty powerful image. I've got another one I'll come back to. And so this, I've already alluded to this relationship between the forest and our climate and what's going on there. And I wanted to see some harder numbers. And I found a very excellent journal article, and this is from that article. And if you want any of these sources, just let me know. Now, what we can garner, and this is just a basic hydrological cycle, but what they've done here is they've added numbers and quantified how much of this water on land, on Earth, is actually being moved around. For instance, they were able to quantify on average how much precipitation Earth gets in a year. They're able to quantify how much evaporation and transpiration came from land back into the atmosphere in a year on average. Okay, so they're able to start putting numbers to what was our elementary third grade water cycle. And this becomes extremely powerful because this is what's key to me is you come in here to land and precipitation. You look at land precipitation, 113. Well, evaporation and transpiration together back into the atmosphere is 73. Suddenly you realize a lot of the precipitation we're getting is coming from the land itself. If we're impairing the land's ability to put rainfall back into the atmosphere, we might be in a roundabout way breaking down the hydrological cycle. We might be creating drought. And there are journal articles in instances where obviously if you go in and you clear cut a lot of land, you could create desertification, okay? And so I think that's really what's going on. And so what I'm getting at here is we need to look at forests and value them even more than we traditionally have. They have more of a value than beyond the red-cocketed woodpecker that we're managing for, and the timber that we're managing for, and the watershed health, and all those great things. I think that the companies like Weyerhaeuser and the loggers and the private landowners and the foresters, by the way, my family, I'm a fourth-generation forester. We have 120 acres of what I have considered some of the oldest growth pine in the valley. But we need to, I think landowners such as that should be compensated, should be respected for the service that they're providing to society, because it really is being undervalued. The way that we manage our land and the things that we do have a direct impact for everybody on Earth and in the future. And we're providing a great benefit to everyone by managing our land the correct way. And so my thought where I'm going with this is that I think that, personally, I think that our state and federal governments should look at forestry and subsidizing those industries and looking at ways of creating different kinds of credits, ecosystem service credits, for instance, that can fuel those industries, keep them vibrant, sustainable, keep areas like Southeastern Oklahoma going and booming. Because this is really the future, in my opinion, okay? There's only so much oil in the ground, we can grow trees forever, okay? Well, until the next ice age, okay? And then we've got a new problem. And that's a joke I make. Luckily, we're not going through global cooling right now because we'd all be moving to Mexico. And, okay, so let's think about that. But there's also something else interesting going on here. I usually don't point it out, but I really want to do it this time. Okay, look at all the water that's coming down, percolating into the ground. And OSU Extension has a fantastic soil trailer they go around. They show you how forested soils, they basically pipe the water down into the water table the most efficiently. Compacted soils out west that are tilled, I guess the high tilled soils, create the most runoff. And so we know that forests recharge our aquifers. Okay, so the composition of our forests and the health of our forests may not only affect our climate and our atmosphere, but it could affect what's going on underground with our aquifers and our groundwater. Okay, and if we pump all of our groundwater out, for instance, it could start affecting our streams and lakes, and that's a okay. So my hypothesis is this, and I want to throw this out there to y'all, is that climate and water cycles of eastern western Oklahoma are somehow linked. Now, I want to go back to a slide on the drought. And has anybody read the book Sawmill? It was written in 1986, I think. It's a really good book. I can't remember the author's name off my head. I can't believe it. But anyway, it's a book on the Ouachitas, and it's described as the last virgin timber east of the Rockies, I believe is the name.
And Smith.
Yeah, Smith. Yeah, it's a fabulous book. But it describes the logging that took place historically, and we don't have much of a historical record, and we don't have a lot of pictures, especially of old-growth forests, and some of those are in there. Now, reading through that book, I realized that he talks about this period of high logging that occurred during the 30s and that occurred during the 50s. And it just happened to coincide with the Dust Bowl and the drought of the 50s. Now, I'm not saying that logging the Ouachitas caused those things, but what I am saying is that if the Ouachitas were never logged, that these events probably wouldn't have been as severe. Now, consider this. They were able to calculate the Amazon forest in a single day is able to put as much water into the atmosphere as is in the Amazon River itself. So every day that forest is pumping one Amazon River into the atmosphere. Well, what happens when you cut that forest in half? You're getting half of an Amazon perhaps, maybe only 3/4 of an Amazon River. What does that do to cloud cover? It might reduce cloud cover, which increases solar radiations on Earth's surface and so on. And so you can see a negative feedback effect there. But we might be able to reverse that with forests and looking and cherishing them for their role in the water and nitrogen cycles, and not so much the carbon cycles. And frankly, the carbon cycle has been a tougher sell, especially legislatively, carbon credits and things like that. And it's been hard to convince people of that. But when you look at the bigger picture of what forests are doing and the services, the ecosystem services that they're providing humanity, they're much larger than carbon. They're much larger than carbon. And so, my last slide here has a journal article, and this is the only reference where I've been able to find where someone has hinted that there might be a connection between our forests, our topography, and our climate. Not only that, but with that out west. And so it's a journal article by Nowlin Preddy and Shapiro and Gorley out of the University of Oklahoma. And it's called The Climatology of Nocturnal Warming Events Associated with Cold Frontal Passages. So I'll explain that real quick. They found that when cold fronts were blowing across Oklahoma, that it was creating these temperature inversions. They were having these hot downdrafts for some reason. And you may have felt one before. We have a cold front coming in, you're outside, you feel that wind hit you, but it's hot for some reason. I remember feeling that when I was young, especially when we had big storms come in. And it would happen on occasion. Well, apparently, from this journal article, this is a phenomenon that outside of Oklahoma has only been observed in Australia. Now, as these cold fronts pass over Oklahoma, they find that these inversions, these temperature inversions, are happening far less frequently the closer you get to the Ouachitas and the forests. And so there's kind of a hanging question, well, does the health of the Ouachitas, would it reduce these temperature inversions? And these temperature inversions, when they come through, can increase surface temperature on Earth 10 up to 15 degrees. It could be at night, the temperature is steadily falling, and then all of a sudden it goes up 10 or 15 degrees for about 5 minutes. And that's what these temperature inversions are. And so it might be a direct link to show that the forests have a propensity to kind of shield or soften the blow. And we all know that our air masses generally go from east or from west to east. Our storms do. So it's not that our forests are pumping water in the atmosphere and that's floating to the west, but it is somehow creating a buffer effect to the rest of western Oklahoma. When you think about millions and millions of acres of trees, we're talking about the entire landscape, Arkansas and Oklahoma. When these cold fronts come through, they are affected by the topography and the forest. They're not a forest that's so great that these things are separate. They are intertwined together. And so we really need to do some more research to do that. And so here's what they conclude in the article, and I'll just read this real quick. It says, in general, Oklahoma's terrain is gently sloping, with height increasing to the west, but the eastern part of the state has much more complex topography. Much of the eastern part of the state is forested, whereas the west is characterized by prairie vegetation and farmland. It is plausible that the combination of forested land surface along with complex topography created shielding conditions that promoted enhanced surface cooling in advance of this mixing. Okay, so again, I go back and I'm thinking, well, we cut down a lot of trees in the 30s and 50s. Did that create a whole bunch of temperature inversions out west? And it very well could, and it may have. And so the farmers out west, and this is what I wish I could do this presentation for them, and I wish they could realize that the way that we manage our land, the health of our forests, the health of our watersheds impacts them. We're not selfish people out here trying to preserve what's ours. We're trying to preserve what's best for the state. This is good for the nation. This is good for the entire nation. The entire nation needs to see a strong, vibrant, healthy Ouachita forest, in my opinion. And I'm sure y'all are familiar with a whole host of ecosystem services that forests provide, from carbon sequestration, purified air and water. They provide food, water, energy, spiritual, historical, cultural, recreational needs. I mean, they do it all. So, and water is life. So that's the presentation.